Welcome to all our panelists. Good to see you, and thank you again for your time. And it's a real pleasure to have you because you represent a lot of exciting development that took place last 10 years in Australia and New Zealand, and a lot of exciting stuff that is coming up online now. So the time is due, so I would please ask Mike to start with your presentation so that we have a little bit of time in the end for questions and answers. So Mike, this is your time. Thank you.
Sure, no problems. Thanks, Jan. Thanks, everybody. It's great to be here. It's a wonderful honour again to be involved with Sheco and Atmosphere. Just want to give a quick information about our market trends as a contractor. So we'll head straight into it. Just as a quick information about us as a company, we are fourth generation, I'm clicking ahead, there we are. Fourth generation family business. So we commenced trading in 1920, so it's our 100th year this year, so we're very proud about that as a business. We sold our first refrigerator 1931. Our first supermarket in installation was in 1955. Started some local packing construction 73. As a WA-based contractor, we saw that we needed to expand over into the eastern states, a much larger market centre. And then we commenced our CO2 journey in 2009, where we did our first CO2 cascade. 2013 was our first transcritical CO2 system. Coming into this year, 100 years as a business, so we're very proud of that as one of the oldest companies in Australia providing refrigeration solutions. So we're a fourth generation family owned business, 5 states, 6 offices where we employ 245 employees and a host of other contractors as well, both for ourselves and also subcontracting. So for us, again, we've got 4 main pillars of our business. Let's just go back one. 4 main pillars of our business. So we do case sales. We also do a lot of refrigeration, which is our core. And so case sales again, refrigeration installation is our core. We also do heating and ventilation, and we're now obviously working on some integrated systems with our refrigeration and air conditioning to supplement the heat and the cooling available. And part of some work we did with a company that we purchased in South Australia, we now offer food service equipment, so we can round out both front and back of house. So market trends. We do see that Europeans influence the Australian market, and that's a big source of information, not from regulations, but also from equipment. And we see that F-gas is driving the shift in refrigerant types, not only in Europe, which then brings it further to the fore in our Australian market. I think for natural refrigerants, CO2 and hydrocarbons are becoming the norm in supermarkets and smaller stores, and with them being more prevalent, we're now seeing a mixture of both remote and plug-in style cases, and that's a drive with both hydrocarbons and CO2. So it's a bit of a stimulus back into the construction of those and design. So just for us, we've got, we're coming up to 30 systems installed. We've got 6 more in progress being in construction. Some reasonably large and small with the systems that we have available. Everybody knows about how hot Australia has been and still will be going in the future. So we're looking at some technology that will allow us to operate these systems in higher ambience in an effective and energy-saving design. So it does bring, I think as the buzzword is, we're shifting the equator, the CO2 equator as south as we can. And we're seeing some wonderful benefits of how we can do that. The next one is about the challenges to our industry. So just some different sizes of our systems there, but the challenges we see are is technology. And as we heard in some previous presentations this morning already, technology is a big challenge. Electronics are taking over. We're seeing electronic valves coming into the place where we're looking at CO2 systems, case controllers versus the good old time clock, the defrosts, and web-based store maps and alarm notification is what we're seeing, because people are demanding information online and instantly. Another couple of other challenges, we are still seeing, unfortunately, high GWP HFC equipment continue to be imported and installed, and a real push is to really try and work on how we can reduce that being pushed into the business, into the industry. And one big barrier to that is the training and upskilling, and we need to work on measures of how we can upskill all of our industry to gain confidence in new technologies. Sometimes we're seeing wrong messages being sent to end users. Systems are too inefficient. It's too new. Well, I think what we're seeing nowadays that a lot of natural refrigerants is going to become the norm. The video you might have seen during the morning tea break was actually a pack that we've purchased to allow us to produce our training centre, and that's going to be developed in our Victorian branch coming in the next 12 to 18 months, which will allow us to in-house train our own technicians on CO2 technology. That's going to make us more real to the industry and understand that we as a business need to put back into training our people. We need to work hand in hand with our TAFE colleges. TAFE do a wonderful job, but we always need to make sure that our people are honed to be the smartest in their industry. One of the other things we're looking at is how to future-proof the industry, and access to the latest technology, obviously via OEMs. Wholesalers and suppliers do a wonderful job. The latest technology of refrigerants as well as equipment will allow the industry to advance. The longer that we have higher GWP gases available still gives people the opportunity to install those. As I said before, engaging TAFE to industry is important. That will allow the training to be a lot more synergistic to the industry, and allow it to become as relevant as we need going forward for an HFC-free refrigeration industry. And look, as the training centre as well, our training centre will allow us to future-proof our own tradesmen as well. Look, that's all from me. I hope I haven't taken up too much time, but look, from our point of view, we see natural refrigerants being the norm going ahead. So thanks, Jan, and back to you.
Thank you very much, Mike. Excellent presentation. Congratulations again on your anniversary, as well as the plans to have the training center. It's definitely the step in the right direction. So great to see a very good progress in Australia. So I will invite our second speaker, Matthew Derby from EcoChill, and he will introduce many of his achievements and his team in Australia and in New Zealand with both CO2 and hydrocarbons. So Matthew, the virtual stage is yours.
Great. Thank you very much, Jan, and thanks, Mike. That was a great presentation. I'm hoping you can all hear me okay. Look, I'm here to talk to you this afternoon about natural refrigerants, and as Mike was just explaining, Bakers are going through their 100th birthday this year. We're fortunate enough to be going through our 20th birthday this year, so a little bit younger, but still very enthusiastic around the natural refrigerant front. EcoChill, as I said before, turns 20 this year. We started working with natural refrigerants back in 2007. And from there, we've gone on to really sort of pioneer the introduction of CO2 into the country. So across the natural refrigerant sphere, be it hydrocarbon or CO2, we've got some 60 plus installations across the country now. I should just point out that those 60 installations often have at least 2, if not 3 packs or racks or units, whatever you want to call them. So we're probably closer to about 150 to 160 installations of plant across the country. Most of those have either been built by us or to our specification, just depending on a time frame in terms of manufacturing. But we do have very specific criteria that we build our plant and our hydrocarbon chillers too. So just a few firsts from us. So we introduced the first CO2 system into New Zealand back in 2007, and that was a subcritical system using a propylene as a primary refrigerant for condensing. And then we went on to introduce subcritical CO2 into a supermarket in 2010 in the North Island, which is the first one in the Foodstuffs North Island. And then the first transcritical system into New Zealand in 2012. And we've sort of gone on from there to do additional firsts. And more recently, we've been working on parallel compression in CO2, which is predominantly in the South Island, but it's something that's becoming an increasing efficiency tool. And but more importantly, I'm here to talk to you today about a much larger hydrocarbon installation. So just in terms of hydrocarbons, I mean, CO2, as we're already clear, it's a very diverse refrigerant, fantastic for split loads, low temperature and medium temperature applications. However, hydrocarbons really do stand out as the preferred refrigerant when we're talking medium temperature applications. And that is something that we've been focusing on now for the last 13 odd years. We've got a number of installations. Again, these 26 installs have at least 1, if not 2, and some have even 3 chillers on the site. So we've got more like 50 to 60 systems in place around the country. And we're currently working on another 4 installations right now. And as I said before, the development of the hydrocarbon chillers is something that we've invested a huge amount of time and energy into. So these are all built to either built by ourselves or built to a very exact specification. I want to talk today about a particular installation for Eastland Port. So looking at this image now, you will see a ship in the foreground, and if you look to the sort of the left-hand side of the frame, you'll see a blue-tinged building. That's the original cool store that was installed in the 70s. There's a tunnel that runs parallel along the side of the cool store. It was originally, as I said before, it was built in the 70s to operate on ammonia. However, that became non-viable in the early 2000s. So the project was handed to us to come up with a solution to reinvigorate the cool stores and create some flexibility around how they're going to be used. So originally an 84-meter long freezer room, we converted it into two separate tenancies, if you like. So that the port had very clear criteria. They wanted to be able to lease out the stores to run independently. And they were also very keen to be able to charge each client based on almost like interestingly, like cooling as a service. They're charging for units of energy used and units of cooling done. So that came along with its challenges. So a very finely integrated control system with very clear parameters. But you can see here the maximum storage capacity for each store is some 1.75 million kilos of product, ranging between 0 and 5 degrees. And the stores, even though they're sort of 40 odd meters long each, we've zoned each one of those stores into 4 zones. So we've got 12 blowers that run down a central aisle for each school store. And then within those 12 blowers, we've separated the store out into 4 individual zones, so we can control temperature, humidity, airflow, and of course we're reporting all the information back to the control system, which the client is then using to on-bill their tenants. So just a few images here of the site getting prepared for the chillers to be installed. So here's the chiller sitting on the pad, in the commissioning phase. So we've got getting ready to pump glycol and water in. So when we were handed the project, it was very clear to us that we had to provide the full turnkey package. So modifications to insulator panel were done with Incold PIR panel. The control system we used was an RDM system, which we wrote all our own software for. We installed integrated LED lighting, rapid riser doors, which came out of Incold, and all of these electronic devices and all of the sensors and so on all report back to the RDM control system, which then goes on to provide a huge amount of data. And that's one of the things that was crucial to the success of the project. And we talked before about data and the importance of it. Well, capturing all of this information coming back into the controls was absolutely critical for a number of reasons. The ports run an incredibly tight health and safety risk management system, so we needed to be able to prove access into the stores and cleaning and management of the system. We also have a duty of care around the product that's stored, ensuring that the product is in the optimal condition as it leaves the store, and that the system is performing optimally. And then, of course, there's sustainability objectives. Eastland Group have very, very tight compliance and reporting requirements, and understanding how the system's performing is all part of that. A little bit more about the system. So there's a central corridor there with the blowers inside, and the two chillers. Each chiller has 4 separate circuits, and each circuit has 14 kilos of refrigerant in it. So across the two chillers, we've got a total of 112 kilograms of hydrocarbon refrigerant as a primary refrigerant, which is providing some 1.1 megawatt of cooling capacity. So a very, very small amount of refrigerant in the primary circuit to go on to provide the overall cooling effect. Some images of the chiller here. You can see the four compressors, 8-cylinder machines, each speed-driven, condensers with EC fans, electronic expansion valves, and individual plate heat exchangers. And there we have the Grundfos EC speed-driven pump, circulation pump in the foreground. There's the chillers in place, in situ and plumbed up, ready to go. And just a little bit of background here on this pipework. So Gisborne is a relatively active seismic area. So we had to ensure that from a health and safety point of view, not only are the chillers able to sort of move around a little bit, should there be a seismic event, but also the pipework is held in position and everything is capable of continuing to run. So quite a difficult task to undertake when we're talking about 250 mil diameter pipe that is containing a significant charge of water and glycol, and allowing all of that to move around in the event of an earthquake, but keep running. So one last little thing here, the cool stores, as I said before, they can run in multiple modes, and the product that's stored within them is variable. So here you can see pallets of export-grade kiwi fruit that are getting ready to go into long-term storage before they're loaded onto a ship. And a lot of this fruit comes in at less than the optimal storage temperature, so we have to pre-cool that product. So we do that using these large boxes, these fan boxes, which draw high-velocity suction of air through the product and then spew it out the top to pre-cool the product for long-term storage. And then it goes into the main chilling halls where it sits in storage waiting for the ship to come and pick it all up. So I guess in a nutshell, for us, the natural refrigerant sphere is all about providing competitive advantage, not to us, but to the end user. So how is it that end users can move away from understanding refrigeration as just building a box and making it cold? Well, it's all about providing them with the competitive advantage of better product that gives them a higher margin. So whether it be fruit or meat or dairy products, natural refrigerants provide us with that opportunity through lower energy use, higher efficiencies, better performance conditions. Yeah, that's it from EcoChill.
Thank you very much, Matthew, for another excellent presentation. It's very great actually to see a complete different answer to when it comes to large capacity industrial refrigeration projects using natural refrigerants. You opting for hydrocarbons, right? I would say it's a fairly unique solution in the context of industrial refrigeration. So very exciting to see a lot of innovation on your end. So thank you again for your presentation. There will be questions in the end of the panel, so please stay with us. With that, for me, pleased to invite our next speaker, Vince Aldino, Managing Director from Fonco in New Zealand. So please, Vince, join us here for the next presentation. Hopefully, okay, there you go. So the stage is yours. Thank you.
Thank you. Thank you, Jan. For those that don't know me, my name is Vince Aldino. I'm from Fonco, New Zealand. We're a commercial refrigeration and HVAC contracting company based in New Zealand. Before I start, I would like to pass on my congratulations to Mike and Peter Baker and the entire AJ Baker team. 100 years as a family-owned business is a remarkable achievement, not only for those who currently operate the business, but for all those who have come before them. I would also like to thank the people at Atmosphere for giving me this opportunity to talk to you about Fonco and what we've been doing with transcritical CO2 over the past 4.5 years. So who's Fonco? Well, originally Fonco was a residential heat pump installation company owned by the Svetkovsky family, who immigrated from Macedonia to New Zealand and started the business in 2001. It remained that way until February 2012, when Fonco was purchased by myself and business partner Jim Power. We both have had a background in commercial refrigeration, myself with 8+ years at Arnhem, New Zealand, and Jim with over 25 years experience with WR in the UK, Arnhem and Climatech in New Zealand. By the end of 2012, we had completed Fonco's first commercial HVAC installation, and it wasn't until late in 2015 that we completed our first commercial refrigeration project, which was a transcritical CO2 supermarket in Whangaparo, Auckland, for foodstuffs. Fonco has grown from the 4 residential installers we originally inherited when we purchased the business in 2012 to now having over 45 staff and offices in both Auckland and Wellington. We have 4 main key revenue streams: commercial refrigeration, where we import, supply and install EPTA cabinets and plant; commercial HVAC, residential AC installations, as well as service and maintenance divisions for both residential and commercial application. In a short time, we've become a preferred contractor for Foodstuffs North Island and Progressive Enterprises, the 2 main supermarket operators in New Zealand. Foodstuffs have bought into transcritical CO2 and are installing this technology in all medium to large format stores. Progressive have until recently been using hybrid systems, 134A CO2 low temp, same as their parent company in Woolworths Australia. But we have, however, started to see changes in discussions and decisions around transcritical CO2 with Progressive, culminating in us starting our second transcritical installation for them starting early next month. With our first supermarket, which opened in November 2015, Fonco has successfully installed 12 transcritical CO2 packs in the North Island of New Zealand. 10 of these have been for foodstuffs, biggest being 460 kilowatt medium temperature and 100 kilowatt. Includes New Zealand's first EPTA FTE system. As stated previously, we've also installed 1 transcritical system for Progressive and soon to start work on our second. We've also installed a system for Life Health Foods, a cold store, manufacturing, distribution and warehousing facility in West Auckland. In addition to the completed projects, we currently have 6 racks landed in New Zealand, all due to be installed by the end of 2020 for both Foodstuffs and Progressive. And we're also working on our second design and build cold store facility. It's envisaged by early 2021, we should have 20 systems up and running in a 5-year period. March 2020 saw us commission New Zealand's first FTE system at Pack and Save Botany with the technical assistance of John Sheehan from the FD UK office just before the level 4 lockdown was announced. This was a retrofit 265 kilowatt medium temperature and 48 kilowatt low temperature system. And we installed the plant with the patented FTE systems so that it can be turned on and off for data gathering purposes. This means that the system can be run in standard transcritical mode or transcritical FTE mode, enabling us to collect data on the energy consumption for each mode on the exact same system. Now you might ask why that's important, but typically it's been difficult to show the benefits of different technologies because no 2 stores are the same. Making comparisons between stores ambiguous due to different size plant, different climatic conditions, age of plant, etc. So having the data from the same store, same plant in different modes will give us more of a conclusive comparison to be able to take back to our client for future decisions to be made. We're expecting to see a 7 to 10% energy saving with the FTE mode activated versus standard transcritical mode, and this data is due to be reported back to the client in October 2020. We've also had our first cold storage distribution centre running on transcritical CO2 for over 18 months now. This was a 252 kilowatt medium temperature design and build project for Life Health Foods with an additional 100 kilowatts of spare capacity for future expansion. The environmentally friendly CO2 fitted well with Life Health Foods' natural image, as well as the ever-increasing costs of HFCs under the ETS. That became an easy decision for the client to go ahead on this one. We're hoping that this type of thinking will start to move forward in other food sectors outside of the supermarket chains. While the supermarket chains in New Zealand are on the right track, there are still obstacles that we need to overcome. One being new decision makers coming into the businesses who either don't understand the technology or haven't been, or transcritical CO2 is not being a standard where they come from. They tend not to realise that they're not comparing apples with apples when benchmarking against what they maybe have been paying for before or what they're used to seeing. This leaves it open for decisions around natural refrigerants to be reversed based on CapEx reasons. Another issue is the low cost of power in New Zealand relative to the rest of the world. In comparison to other markets, the return on investment for any type of energy saving technology is considerably longer here than it is in other places. Engineering skills, well, we're no different to the rest of the world. Good refrigeration engineers, installers, designers are all in high demand, and there are not enough skilled engineers in the marketplace. When you add in the factors that we are one of the most isolated countries in the world and that we would like CO2 experience to be a prerequisite, then the talent pool becomes considerably smaller than it already is. Another issue that we've encountered is having the availability of CO2 specific parts in the marketplace. We've had to change the design of our plant so that we have backup ICM and CCM valves on every rack that comes into the country, as well as having to increase the internal stock levels to cater for emergency situations. Now, we're fortunate to have the technical backup of a company like EPTA, where we can get parts quickly from overseas at OEM rates. But if the technology is to grow and to become the norm, this is not necessarily a luxury that other contractors have or would be willing to take on. So as mentioned previously, skill levels on transcritical CO2 is a hindrance for the technology being more widely utilised. Fonco, like many of our peers, realise that the long-term answer is to be bringing through more apprentices to increase the ranks of engineers in the industry. However, the current apprenticeship training blocks available within New Zealand don't have much, if any, focus on transcritical CO2. This is instead left to on-the-job training to gain the necessary experience, where the apprentices get the guidance from their training engineer and the amount of transcritical CO2 that they're actually exposed to. And what we've found is that the engineers that come from outside of the three main CO2 contractors have no experience or little understanding of the technology that they're going to be working on. So with this in mind, Fonco is looking to develop our own CO2 training modules that will cater from a first-year apprentice right through to a design engineer, with tailor-made modules to help progress their skill levels and confidence while working on transcritical systems. It also allows them to progress higher up the ranks if that's what motivates them from a professional development point of view. So what's the future for Fonco and natural refrigerants? Well, we will continue to offer transcritical CO2 as the norm in the refrigeration sector. That is what we do and who we are. We will upskill as much as possible, enabling our people to learn and develop as the technology evolves, and as a byproduct help to increase the skills and standards of the industry as a whole. We need to be able to offer natural refrigerants to our customers for both refrigeration and HVAC, giving them a fully natural solution. At the moment, we talk natural on all refrigeration projects, but revert back to a status quo on standalone HVAC projects, for example. We've made some small gains with companies like Temperzone in terms of changing their thinking towards alternative refrigerants, but we now need that thinking to go natural. In the future, we want to be offering natural solutions to all of our clients, no matter what type of project it is that they're putting in front of us. To offer a natural refrigerant rooftop package unit, chilled water system, hybrid VOV system that air conditions a supermarket that's running on transcritical CO2 refrigeration is a goal that Fonco is dedicated to achieving, hopefully in the very near future. Thank you for listening.
Thank you very much. Again, another very interesting presentation. A lot of case studies and very ambitious plans. So I understand the upskilling is a big focus for the industry, and I would also like to invite our previous panelists, Mike and Matthew, to join us here for about 9 minutes of Q&A. So allow me to touch on the last point that you made regarding use of natural refrigerants in the HVAC solutions. So you mentioned a number of technologies and sectors that you would like to serve. I would like to ask Mike and Matthew, what is their take on use of natural refrigerants in HVAC over the next 10 years? Which technologies do you see to be available eventually, shortly in, let's say, 1 to 2 years? Which refrigerants and which sectors are you looking into serving with natural refrigerants in the HVAC sector? So this is a question for Mike and Matthew. Maybe Mike, you can start.
Yeah, look, thanks, Jan. We're seeing a slow uptake, but there are some end users that are willing to put both CO2 into heating and refrigerant cooling. But a lot of the times the building itself, the box is done by a separate contractor, so it is very difficult to try and bring the synergies together. We are slowly working with some of our major clients to get those synergies taken away from a builder and given to us. We've actually done a couple of installations over here with natural gas heat pumps and for cooling, so gas-driven engines, and that's been quite an achievement. There's a fast food chain opening up here in Perth quite soon with a gas engine for heating and cooling. But combined systems, we are working towards some solutions for that, and we see that as a step forward.
Thank you. What about New Zealand and the NatRefs in VLAC? What do you see the future to be like, and what are your projects?
We're seeing something similar to as Mike was explaining. There's a situation where if the building is constructed by a third party, it's pretty difficult to come along afterwards and try and integrate some kind of natural refrigerant system. However, where we're part of the design build process, and particularly where there is a need for integration of both the refrigeration function and there is a lot of either surplus heat or opportunities for dehumidification and so forth, it's becoming an easier process to run through. But of course, the challenge that we have always is that capital cost versus the longer term benefit. So that's always a struggle. But as synthetic refrigerants become more and more expensive, we are seeing a shift in the customers' attitude towards the natural refrigerant opportunity.
Excellent. Thank you. Let's look at the role of the regulation and policy. Are you all familiar with the EU gas regulation? We are actually just starting the process of the third version of the EU gas regulation in Europe. And the goal for the next iteration is to introduce more ambitious targets for the air pollution. My question to all of you, starting with Mines, is the role of regulation and what kind of policy, what kind of measures would you welcome to see for the policymakers in New Zealand and Australia in order to accelerate, let's say, this transition for both refrigeration and air conditioning in the future?
Sorry,
who's that to?
Yes, please, if you may start.
Okay. Look, from a personal point of view, I always struggle with regulation dictating what has to be done, but we may have to get to a point where that does happen to a point. We would like to see the end users make the decisions to go down these ways without having been told. But for instance, the glass door theory on a multi-tier cabinet, for instance, in New Zealand, it's reasonably obvious that the two main players aren't going to make a serious play on that unless one goes before the other and takes that big risk, which I don't think they're willing to do. So regulation has a part going forward. Where and how that gets done, that's for politicians and people that get a lot higher in it than me. But what I would like to see is the end users make those decisions rather than being told to.
Thank you, Mike. Maybe you can speak.
Yeah, in Australia, it's quite a state-based regulatory system. Obviously, we have the overarching MEPS and GEMS regulations for display cabinets, but incentives for end users to work towards an energy efficient solution is very spasmodic. There's only really two states of Australia that look at giving incentives to end users to go to a more energy efficient solution. So something as a more structured system across the country would benefit that, and that would uplift the use of more energy efficient display cases, different styles of refrigerants as well. So it is a bit of a tiered thing between regulatory being the big hammer and then incentives to actually do it. So, we're seeing obviously the big hammer in Europe with F-gas, but in Australia it's an end user price driven system for refrigeration quotas for imports. So there is a balance, as Vince said, between the two, and I don't think anybody has the silver bullet to make sure it works properly. But the more discussion we have and the more interaction we have as a full industry, I think the better we can get towards a better result.
Thank you. Matthew, if I have a quick answer, please.
Yeah, I agree. There is an amount of the technology in the country that we are we're largely technology takers here in New Zealand. So whatever happens up in Europe is eventually filters down here to New Zealand anyway. So in terms of new technology and the country grappling with how to introduce that, that's just an industry issue that we'll always have. I think also we talk about training, and it's interesting that right now there's a select committee that's been put together by the government operating under WorkSafe to introduce a mandatory refrigerant license into New Zealand, and they're looking to try and have that established by this time next year. So I think that things like that will have a significant impact on our behaviour at a sort of an operational level or an industry level. But as both Mike and Vince have said, at the end of the day, there's a couple of big ugly sticks that the government wield, being the ETS and the HFC phase down, that both of those drive behaviour through increasing costs of refrigerants and the reduction in availability of gases that just literally mean the technology is forced upon us anyway.
Thank you very much, Matthew. I'm looking at the time that we have. There's about a minute left. I have a question. I would like to ask one of you, please choose who would be the best position to answer. What is your take on the use of natural refrigerants in industrial refrigeration? We see a lot of heated discussion between the ammonia guys, CO2 guys, and now we hear more about the solutions using hydrocarbons from Matthew and others, the large capacity refrigeration system. So being an end user, how can I make my, what can I make out of it? What is the solution to choose for? What are the main factors to look at? Of course, this varies country to country and user to end user, but is there any common denominator for this discussion?
No, not at all. I mean, we play at EcoChill, we use all three refrigerants, and there is not one refrigerant that is suitable across every application. I mean, as we've talked about earlier today, there's hydrocarbons are fantastic for the medium temperature applications, but then again, CO2 has huge amounts of waste heat that we can reuse. But then ammonia just is a bit more suitable for certain industrial applications. But so I just think that as long as whoever's doing the system design is clear on what the customer's long-term expected outcome is, then there is a solution using natural refrigerants regardless.
Thank you very much. I believe that we can all agree with that answer. Does it represent your take as well, Mike and Vince, if you'd like to add anything? Okay, then thank you very much. We have reached our time. I would like to thank you all again for excellent presentations and your participation in the panel and in the conference. So thank you again. And with that, I would like to give words to our colleague Caroline and the panel. Are we ready for the future? Which is very exciting with our all-female participants. So please welcome everyone again, and thanks again, guys, for joining. So we'll be tuning out. Please remember to close your browser so we are ready for the next panel. Thank you. Bye.